Hi, Algebra 2. This is Unit 4, Lesson 6, and today we're going to be talking about exponential growth and decay. Okay, so we're going to be doing some word problems to figure out growth and decay. So growth, this is what we're going to use. A equals P times 1 plus R to the T. And if I'm doing decay, I'm going to use A equals P times 1 minus R to the T. Okay, so this R is just representing the rate. Well, I wrote so some examples. Let's look at examples first. Examples of growth are population growth, cell growth, a virus is spreading, nuclear reaction, economic growth. So it could be talking about money in a bank account, anything like that that's growing. Exponential decay can be chemical reactions, prescription drugs, radiation, motor vehicle values, your car depreciates, retirement funds. Okay, so any of that can be decay. P stands for the initial amount. Okay, so if you're putting money in the bank, that initial amount that your principal. R stands for the growth or decay rate per time interval. You must convert a percent to a decimal. So the way that you convert that percent to a decimal is you just do percent over 100. Or you can just remember to take that rate and move that decimal 2 places to the left. And T is the number of time intervals that have passed. All right, so let's look, because it's really not that hard. And you have both of those equations right there. So the U.S. population was 281 million people in 2000. That is my P. That's my initial amount. And that's in the year 2000. The population increases. So I'm talking about growth because it increases. The population increases at an annual rate of 1.24%. So my rate, I need to take that 1.24% and I need to change it to a decimal. So I'm just going to move that decimal over 2 places and it's 0.0124. So I took the decimal right here and I moved it 2 places to the left and it became 0.0124. Write a function that models the U.S. population growth in millions after 2000. Use this function to predict the population in 2020 rounded to the nearest million. So I'm starting in the year 2000 and I want to find the population in 2020. So my time is 20 years. All right, so my function is going to be P, 281, times 1 plus the rate, 1.0124, time to the T. T can be any rate of time. Now we know we want to evaluate this. What's the population going to be in 2020? So I'm just doing 281 times 1 plus 0.0124 to the 20th power. Now remember on your calculator, to get any exponent right above that division symbol, right? Right above the division is that little up arrow, that caret symbol. And that's what I'm using. So this is going in my calculator exactly the way it is. All right, and out pops the answer of 359.5, and I'm rounding this to the nearest million, so that would be 360 million people. And that's how this works. Okay, so you're just using those formulas. You got the growth formula, the decay formula. They're really similar to each other, and you're plugging in all the information that you know. All right, Brian's car has an annual depreciation. All right, so I'm depreciating it. I'm talking about decay. So I'm going to use A equals P times 1 minus R to the T. The rate is 8%, so my rate is 0.08. I need to change that. If the car costs $25,000 when new, that's my P. So my P is 25,000. What is the value of the car after 4 years and 3 months? Now, I need to make that time into a decimal because I can't talk about years and months. If I have 3 months and a year has 12 months, 3 out of 12, so basically I have 4 years and 3 months out of 12 years is 4 1/4, but I'm just going to make that 4.25. So that's the number that I'm going to use for my time. I just wanted to show you where that number came from though. So I'm doing 25,000 times 1 minus 0.08 to the 4.25. And that whole thing just goes in my calculator exactly the way it is. Your calculator's doing all the hard work. You just pick the formula, make sure you have the P, make sure you have the R, make sure you have the time. $17,540.35. So that's what the car is worth. Cars depreciate over time. Let's try a few more on the back, and we will try some more of these tomorrow. Oh, we got some multiple choice on the back. Those are always fun to do. If the population of a town is decreasing, so I'm decreasing by 4% per year, okay, so my rate is going to be 0.04. I'm taking that decimal and I'm moving it 2 places to the right because this is 4%. My decimal's here and I move it 2 places this way. So my rate is 0.04. I started with 12,500 residents, so that's my P, my initial amount. Which of the following was the projected population in 10 years? So my time is 10 years. Now just make sure you're using the right one. I am doing decay. So 12,500 times 1 minus 0.04 to the 10th power. And all of that goes in your calculator. So these are not hard at all. And that's 8,310 people. Okay. Which of the following gives a savings S in an account if $250 was invested at an interest rate of 3% per year? So then my rate is 0.03. My principal was $250. And I don't know the number of years. I'm just writing the equation. Okay, so let's look at these. I'm doing growth. So it's 250 times 1 plus 0.03. And the only thing I'm missing is the time. I don't have the time. Okay, but I'm still using my same exact formula. I just don't have the time. I'm coming up with the equation here. I'm not coming up with an actual answer. 1 plus 0.03 is choice 2. 1.03. All right. 5. The average annual cost of a 4-year private college is $31,231 in 2016. This was a 3.6% increase from the previous year. If the cost of college increases by 3.6% each year, what will be the average cost of college at a 4-year private college in 2020? Okay, so I'm talking about P is my initial is 31,231. R is my rate. I'm going to move that decimal over 2 places, so 0.036. And I'm going from 2016 to 2020, so my time is just 4 years. Right, so the cost, I'll call it C for cost. P times 1 plus 0.036 to the 4th power. And that all goes in my calculator. So by 2020, my final cost will be $35,976.99. Try some of these in your calculator. Make sure you can input them correctly. Otherwise, ask me in class tomorrow. All right, and we're not going to do part B. I'm not going to do this at all because part B you actually need to know how to use logs for, so that sort of snuck in that part.